All right, here we go, classic marble problem. So we're going to talk about today the difference between selecting frequencies with replacement and without replacement. Replacement means you put it back. Without replacement means you don't put it back. So you got a bag of marbles that contain the following distribution. What is the probability of blindly picking 2 red marbles in a row if you replace the marble after each selection? So the first thing you need to do is add all the marbles up. So we'll go 10 plus 12 plus 3 plus 14. That gives me a total of 39 marbles. So if I want to find the probability, and here the key is if you replace them. So we're going to go ahead and replace them as we go. So the probability of picking a red marble, well, first of all, we got 2 spots that we have because we're picking 2 marbles. This will be marble number 1. This will be marble number 2. Probability of picking a red on the first one is 10 out of 39. And the probability, if you put it back, of picking red on the second one is also 10 out of 39. If we're trying to find their combined probability, and they're independent, which they are because we put it back, we can multiply them together. So in your calculator, you can do 10 out of 39 times 10 out of 39. Oh. And then if you hit the math, enter, enter, you'll get the fraction. And that gives you 100 over 1,521. Boom. Done. Next one's very similar. You have to read really carefully. What's the probability of picking 3 green marbles? So we're picking green marbles, and we're actually picking 3 of them this time. So I like making my little spots. This is going to be marble 1 that I pick. This is going to be marble 2. This is going to be marble 3. The probability of picking 3 green marbles, but we're not going to replace them after each selection. So the probability of getting a green marble on the first one, remember, this is out of 39. So we're going to go 3 out of 39 to begin with. Then if you think about it, you took 1 green and 1 away, so now you only have 2 marbles that are green. And you took a total marble away also, so you're going to have 38 total to choose from. And then finally you're going to have 1 green marble left over 37. These are not independent events because every time you pick a green marble, it affects the probability of picking a green marble on the next try. So we accounted for that by subtracting 1 every single time. And then we can go ahead and they're combined events so we can multiply them together. So we're going to go 3 out of 39 times 2 out of 38 times 1 out of 37. That's going to give us, if I hit math, enter, enter, very small probability, 1 out of 9,139. And again, probability can be written as a fraction like that. It can be written as a decimal, 0 point whatever. Or it can be written as a percentage, like 13%. Okay. Cool, so you guys are going to try a couple. What's the probability of either selecting a red or a green? So a red or a green. Notice the notation here, or we use the notation U for union. So red or green marble, if we have our first 2 selections, if we, again, do not replace them. If we don't replace them. So what you have to do here is you have to add together. So again, this is out of 39. We're selecting 2. So make 2 little spots. We're going to be multiplying together. We're not replacing them. So how many green union red do I have? Well, I have 10 green, or sorry, 10 red, 10 red, 3 green, which gives me a total of 13 red and green. So the first thing, first spot 1, marble, and spot 2, marble. It's going to be 13 out of 39. And then we're going to go ahead if you do not replace them. So it's going to be, we took 1 away. We don't know if it was red or green, and we don't really care. We just know that we have 1 less, and then we have 1 less here as well. So we do that, 13 out of 39 times 12 out of 38. Math, enter, enter. So I got, you can either say 10.5%, 0.105, or if you go math, enter, enter, you can get 2 out of 19. So the probability is actually pretty good, 2 out of 19. Much better than it has been. What is the probability to select a red and a yellow marble? So for and, that's called an intersection. You're looking for where the red and the yellow marble intersect. So look at our little chart here. It's out of 39. Do I have any red and yellow marbles? I would say no. And the reason why is because all of these selections here are disjoint, meaning that they don't overlap at all. I can't have a red and a blue marble at the same time. There's no red-blue marble. There's no blue-green marble. There's no red-yellow marble. So the probability of picking that is going to be 0 because they are disjoint from each other. You might also see that called mutually exclusive when you have no overlap. It either has to be one or the other. What is the probability that you don't select a green marble on the first try? So the notation here, I don't know what's going on here, but the notation here, the probability of that little tilde means not green. So there's a couple different ways you can do it. This is out of 39. We're only picking one marble. We don't have to worry about replacing or not replacing. So not green. So that's going to be 10, because this is not green, this is not green, and this is not green. 10 plus 12 plus 14 out of 39. So that's going to be 0.92 or 92%, or math, enter, enter. Math, enter, enter. 12 out of 13. There's another way you can do that. So because all of these probabilities, all of these distributions have to add up to 100%, what you can do is you can do 1 minus the probability that you have a green marble. So if you like it this way, that's fine, but there's actually an easier way to do it. 1 minus the probability of green. So 1 minus the probability of green is going to be 3 out of 39. So if I do 1 minus parentheses 3 out of 39, math, enter, enter, I should get the exact same thing. And I do, 12 over 13. Okay, so that's kind of a nice little trick to remember. If you're trying to find the probability of not something, that's 1 minus the probability that you do get that something. And we're going to expand on that as we go. I think we got 2 more. What's the probability you select a blue marble followed by a green marble if you do not replace them? So again, here we go. This first one's going to be a blue marble. I don't know why I capitalized blue. And then we got a green marble after that. So we got 12 blue marbles out of the total, and we know that there's 39 total. Times, now how many green marbles do I have? I have 3 green, and you have to think, do I need to subtract 1 from that 3? I would say no, because the first marble was blue, so we still have 3 green marbles to choose from, divided by, now, we took 1 out, and we're not putting it back because we're not replacing them, so we have 38 total. So we got 12 over 39 times 3 over 38, math, enter, enter. I got 6 over 247. Really helps if you have that TI calculator. Last one. Finally, you select 4 marbles at random. 1, 2, 3, 4. What is the probability you do not select a yellow or a green marble if you replace them as you go? So here you go. If you replace them as you go, that means all of these denominators are going to be 39. Now we don't want a green and we don't want a yellow, so let's go through. We can use this one and we can use this one. So 10 plus 12 is going to be 22. And go ahead and we're replacing each one as we go. So each event is going to be independent of the other one, meaning the first marble does not affect the second marble, and the third marble does not affect the fourth marble. And then because we're trying to find their combined probability, we can go ahead and just multiply them together. So this is going to be a crazy number. Actually, you can write it like this, 22 over 39 to the 4th. If you want to leave it like that, that's fine. I can figure out what it is real quick. Divide by 39 to the 4th. Choo, choo. Math, enter, enter. Ooh, it won't do it for me. So I got point. You can leave it like that, or you can do 0.101, which is approximately 10.1%. All right, there you go. We'll dig more into this coming up tomorrow. See ya.